Welcome back again. Not sure how many days it's been since you've heard me talk, but here we go. Alright, so this is 9.4. This is the last section in Chapter 9, if you're choosing to do Chapter 9. So this is how we graph sine and cosine. So this is graphing sine and cosine. Alright, so what I'm going to do is I'm going to show you the parent functions for both of these things. It's y equals sine of x and y equals cosine of x. Now this may be a little bit challenging to kind of figure out, but basically for every x value that we deal with, and this is all going to be in radians, so everything that we're going to be graphing is in radians. Believe it or not, it's easier to graph in radians than it is to graph in anything else. So the x values that we see are going to be the radians, and those are going to be negative 2 pi, they're going to be negative 3 pi over 2, so it's all going to be in increments of half pi, negative pi, and then negative pi over 2, and then 0, and then we're going to repeat that pattern. So pi over 2, then 3 pi over 2, and then 2 pi. Now the reason that we did this is because if you look back at the unit circle, if we look at this, all of these numbers are really easy, because if you look at pi over 2, here we go, if you look at pi over 2, notice the values of cosine and sine, the values of x's and y's, are just going to be 0 or 1. 0 or 1, 0 or 1, 0 or 1. So this is going to make it really easy for us, because it's not going to have any nasty radicals, it's not going to have any nasty halves and things like that. It's all going to be specifically 0 or 1. Okay? So if I look at this, if I want to see what happens to sine, and if I want to see what happens to cosine, then I can just look at the unit circle, and I can see that the sine value at negative 2 pi is 0, the cosine value is 1. Then it's going to be 1 and 0. Then it's going to be 0, negative 1. Then it's going to be negative 1 and 0. Then it's going to be 0, 1, and then it's going to be 1, 0, 0, negative 1. I don't have you guys to yell at me if I made a mistake, so I have to be really careful doing this. So this is what that table looks like. Okay? So since that's what the table looks like, now all we really have to do is we just have to figure out how that looks on a graph. So this is just the parent function, remember. Okay? So now this is the parent function, so give me 1 second. So if this is the parent function, on the parent function now, we just have to graph this thing. Now it's a little bit different to graph this, because now we have to have a different looking graph. So this graph is going to look like this, but now we're going to have our different periods, or our different labels. So negative 2 pi, negative 3 pi over 2, negative pi over 2, 0, and then we're going to have pi over 2, and then we're going to have pi, 3 pi over 2, and then 2 pi. And so if we look at this, now I'm just going to plug in my points. So at negative 2 pi, the point was 0. I'll do this in a different color. Negative 2 pi was at 0. At 3 pi over 2, it was at, I'll make a 1 and a negative 1, so negative 3 pi over 2 is at 1. Negative pi was at 0, and then negative 1. And then 0, and then 1, and then 0, and then negative 1, and then 0. So a sine curve looks like this. Okay? Doing the same exact idea with cosine, all we're going to do is graph the same thing and plot the points. So it's going to be negative 2 pi, negative 3 pi over 2, negative pi over 2, and then we have 0, and then we just repeat going the other way. And now I'm going to do the same thing. I'm going to plot my points. So I have my cheat sheet right next to me. If you have to flip back and forth between the pause screens, that's okay. But now we just repeat it. So I have my 1 and I have my negative 1. So now this is going to be 2 pi is at 1. And then I have 0. What the heck? There we go. And then 0. And then negative 1. And then 0, 1, 0. Negative 1. Notice how it's just a pattern that keeps repeating. That's all sine and cosine functions are. They're just repetition. It's just a wave that keeps going on back and forth and back and forth. So that's what cosine looks like. Okay? Notice they almost look the exact same, right? It's just this one, if we shifted the sine function left, it would look exactly like the cosine function does. That's kind of what happens. Alright? So, now a couple of definitions. Alright? Notice the range. Remember, the range is all the possible y values of our graph. I'm going to see if I can do this on this page. Notice the range. Range is what the possible y values are. So if I look from bottom to absolute top here, I only went from -1 to +1. So the domain of this thing, or the range of this thing was from -1 to +1, and it included those values. The domain of this was every single x value, because it can go on forever left and right. So that means that the domain is all reals. Okay? Now the amplitude of this. Amplitude is talking about the height. Amplitude is talking about the height from the x-axis to the top. So I'll do that in like a color coordinating thing. I'll try to. Amplitude is the height from x-axis to the top of the curve, or it could be the x-axis to the bottom of the curve. They're symmetrical, so it doesn't matter. So the amplitude in this case was 1. Okay? A period. A period is something that repeats the same cycle. So it's something that is the same cycle. So I guess to define period, it might be easier to talk about cycle first. But if we talk about a cycle, we're saying a cycle is like the same shape that gets repeated. So if I look from here, and then I look at this part right here, that thing is the cycle, because that's the thing that gets repeated. Now a period is basically how long it takes for that thing to be completed. Okay? So when I talk about a period, I'm really talking about this distance from here to here. So the period had a length of 2 pi, because it took 2 full pi for that to actually happen. The cycle is the thing, the period is how long it takes for that thing to be all done. Okay? So those are just some kind of simple definitions that go along with these things. Again, if you have questions, please make sure that you say something. Please make sure you say, hey, I don't understand what you're talking about. I don't understand these definitions. Again, I can't really write all that stuff down because it's super hard to write on this thing. But if you have to rewind and re-watch and re-ask, that's totally fine. Alright? So now, obviously the thing that we can do is we can change these functions up a little bit. Now if we change these functions up a little bit, really what we can do is we could say that we have the same thing that we've really always done. We could have a sine of bx, or we could have y equals a times the cosine of bx. And a is still doing the same thing that it did before. A is a vertical stretch or shrink. And then remember that b is a horizontal stretch or shrink. I know I spelled that wrong, but I'm not going back to fix it. So this is not, I mean, obviously both of these things show up in both functions, so it's not just, I didn't line it up like that on purpose, but obviously it is both of those functions. Okay? So there's a couple key points to graph on these things. I'm going to put these on my notes, but to keep the video short and to keep it so that you to keep it so that you don't have to, you know, suffer through this. If you want to look at your book, this is in your book in section 9.4. I'm going to show you one with sine so that you can see how it really works. But if you want to look at the cosine, look at your book, because a lot of you don't really care. You just want to get to the good stuff, which is what are the formulas and how do I do them, which is totally okay with me. So really there are 5 key points. And again, I'm only going to do this for sine for time's sake. If you want to see more, just ask me, and I will definitely make sure that I can fix this for you so that you can see it. Y a sine of bx. Now obviously these are both going to be numbers, but if I look at what's happening here, my curve is still going to look the exact same. Curve is still going to look the exact same as it did before, but now I'm going to have 3 different key points, or 5 different key points. Those 5 different key points are going to be 0, 0. There's going to be a point up here, there's going to be a point here, a point down here, and a point here. Now there's kind of a formula that you can use. All of these are going to have the same ordered pairs, where it's going to be 1/4 times, and it's going to be 2 pi over b, comma, whatever the a value is. This one in the middle is going to be 1/2 times 2 pi over b, comma, 0. This one at the very bottom is going to be 3 over 4 times 2 pi over b, comma, negative a. And this point at the very end is going to be 2 pi over b, comma, 0. Now, think about this. We're breaking this thing up into 4 parts. 1 part, 2 parts, 3 parts, 4 parts. That's where the 1/2, 1/2, or 1/4, 1/2, 3/4, and then full number come from. All right, so that's where those numbers come from. A is just the amplitude. So positive A and negative A just means you go that far up or that far down. Okay? So when you look at these, it's the same kind of thing. And these are the exact same points for cosine. They don't change. You still use the exact same things, it's just going to be shifted to the left. So you're still going to use 1/4 times 2 pi over b. You're still going to use 1/2 times 2 pi over b. You're still going to use 3/4 times 2 pi over b. All of that stuff is going to stay the exact same. It's not going to change. Okay? So let's look at a graph of this. We could do, it doesn't really matter, we can do a sine function or a cosine function, so you can see one of those too. But if they ask us to graph, if it wants us to graph, we could say y equals cosine of, actually hang on, if it wants us to graph y equals 2 times the cosine of pi x. It tells me that A is 2, and it tells me that B is pi. So now I'm just going to plug those into the exact same 5 points that I had before. So point 1, remember, actually they're not quite the exact same. So I should, so with cosine, if you're looking at your book, which you should do, if you're looking at your book, point 1 is going to be the point 0A. Point 2 is going to be the point, now they start to be kind of the same. So it's going to be 1/4 times 2 pi over b, comma, 0. 3 is going to be 1/2. This should not be negative 1/4. If that looks like a negative 1/4, it shouldn't be. It's just supposed to be a parenthesis. So I have 1/2 times 2 pi over b, and then negative a. 4, I'm going to have 3/4 times 2 pi over b, comma, 0. And then the last one is going to be just 2 pi over b, comma, a. Alright, so those are the 5 points. If you're interested, you can look in your book to see those. But now all I'm going to do is I'm going to plug in my a and my b, and that's going to give me all the values I need. And once I have all the values that I need, then I'm just going to graph that thing the exact same way that I normally would. Okay? So I have 0, comma, a. So my first point is going to be 0, comma, 2. Easy enough. My second point is going to be, I'm going to plug everything in. 2 pi over b is pi, and then comma, 0. Now this is kind of nice because if you notice, every single one of these questions has 2 pi over b. And you're also going to notice here that every single one of these times 2 pi over pi is going to cancel to just be 2. So that's going to be the same thing as 2 over 4, which is the same thing as 1/2. So it's going to be 1/2, comma, 0. Now I already know that every single one of these is going to do the same thing. It's 2 pi over b for all of these, so that's always just going to change to 2. Alright? So the first one, or the next one right here, I see 1/2 times, and then I know I'm going to plug in pi already for that, so it's going to be 1/2 times 2, which is just going to be 1, comma, negative a. Negative a is just negative 2. I'm going to do 3/4 times 2. 3/4 times 2 is the same thing as 6/4, which is 3 over 2, comma, 0. And then the last one is just going to be 2 pi, comma, negative 2. I'm sorry, positive 2. Alright, so I've got my 5 points. Now I'm just going to put those on my graph. And when you graph a sine or cosine function, you really just care about one cycle. So you just care about one period and one cycle. So I'm always going to start with a big line to the right, and then I'm going to have my origin, on the far left of this thing. So now I've got my first point, which is 0, 2. So I'm going to call this 2. Here's 0. Okay, I know that 1 is obviously halfway in there. And then I'm going to look at my my labels. 1/2, 1, 3/2, and 2. So I'm going to go 1/2, 1, 3/2, and 2. So now 1/2, comma, 0 is going to go here. 1 is going to go to negative 2 down here. Now I'm just making sure that my labels are appropriate. And then once my labels are appropriate, then I'm good. So I know that that's 1/2. I know that this one's 1. I know the next one is 3/2, comma, 0. And then finally I know the last one is going to be 2 pi, comma, 2. So it's going to look like this. And I'm just going to make sure that I sketch the beginning of that curve too, because I know that it starts out and it just keeps moving like that. So that's how we graph cosine. Okay? Tried to keep this one a little bit shorter. Again, I'm trying to kind of fly through these lessons and give you the abbreviated version of them. If you have questions, you have to make sure that you ask me. You have to make sure that you say something. Okay? this is the end of Chapter 9. You will have a performance task over this whole thing. So if you have any questions on that at all, at any point, please make sure that you let me know. Alright, catch you next time.